When studying shapes, you may have come across this property. The sum of all exterior angles of a shape equal 360 degrees. Remember, an exterior angle is the angle made when we extend the side length beyond the corner. Here, I've shown the exterior angles in red. And those three red angles added together will give us 360 degrees. Let's go a little bit deeper into this. This is Mr. Butler Maths, and in this video, we are looking at exterior angles. I'm going to demonstrate the property I introduced in 4 different shapes, and then show you a case where it doesn't work. I think the animations in this video are really satisfying, which should help this property of shapes stick in your memory. Let's start with a triangle. Because we're focusing on exterior angles, I'm going to overextend the sides straight away. I'm then going to indicate my 3 exterior angles. And remember, we're looking to show that the sum of the exterior angles equals 360 degrees. How can we show this? Well, let's slide all of those angles together. When I do this, I see it forms a complete circle around a center point. You could also think about this as one full turn. How many degrees is one full turn? Well, that's 360 degrees. So just by moving those 3 angles together, I've shown that they add up to 360 degrees. Notice, as I've done this, I haven't changed the angles at all. They haven't been stretched or squashed. They've just been shifted along. As a result, if the 3 angles at the end make a full turn, 360 degrees, the 3 angles at the start in total must have also made 360 degrees. Let's now move to a second example. This time, we're just going to chuck in an extra side. We've now got a rectangle. 4 sides gives us 4 exterior angles. As it's a rectangle, all those exterior angles are 90 degrees, right angles. Remember, we're trying to show that the sum of the exterior angles is equal to 360 degrees, so that they all add up to one full turn. So again, let's slide them together. Let's take the top left one and slide that down, then the top right one and slide that down and across. Finally, the bottom right one, we're going to slide left. And, just as before, we have those 4 angles combining to make one full circle. And that full circle represents one whole turn, 360 degrees. Therefore, our original exterior angles must have also summed to 360 degrees. In fact, you probably could have recognized this right at the start because they were 90 degrees, and 90 degrees multiplied by 4 is 360 degrees. This one's probably the most obvious. Let's now move on to a pentagon. My pentagon is a regular 5-sided shape. I'm going to highlight all of my exterior angles again. We're going to move around these exterior angles to show that they add up to 360 degrees. As I bring them all down to the bottom left, again, they make a full circle. Let's go backwards to show that again, a little bit slower this time. You can see all of the angles converging on this bottom left corner to form a full circle. And as a result, the original angles must have summed to 360 degrees. So this seems to work with regular shapes, that is, shapes with the same side length and same angles. But what about an irregular shape? To make an irregular shape, I'm just going to put some lines down. I've got one there, one over here, one going up there, one across, fill in that gap, one down, and one across the bottom. So I've now made an irregular shape. Those side lengths are all over the place. It's quite a mess. I'm going to mark my exterior angles. Now I have 1, 2, 3, 4, 5, 6, 7, 8 exterior angles because it's an 8-sided shape. And we want to see if those exterior angles still add up to 360 degrees. Our process is going to be exactly the same. We're just going to slide them together to see visually if they add up to one full circle, which would tell us it would be 360 degrees. And again, we see that it still holds. Even with an irregular shape like this one, the sum of the exterior angles is still 360 degrees. I'll run through that again a little bit slower this time, and you can see they make a full circle in the center. Okay, so they work with this type of irregular shapes. Are there any types of irregular shapes they won't work with? Here is another irregular shape. This one has fewer sides, but there's one feature of this shape that makes it different from all of the other shapes we've looked at. And this becomes obvious as I draw my exterior angles. I could put the purple one in, the green one, the black one, all as normal. The problem becomes obvious when we turn to the 4th one. Here, the exterior angle looks like it should be on the inside of the shape, but that can't be right because then it wouldn't be the exterior angle. So let's draw it on the exterior of the shape. This is tricky to do because this interior angle is greater than 180 degrees. And this is the first interior angle that we've seen that's over 180 degrees. When we have a shape like this, we call it a concave shape, because it has that interior angle bigger than 180 degrees. So we're a little bit confused about which angle exactly should be our exterior angle. Are the exterior angles still going to sum to 360 degrees? Well, let's slide them all together and see. I've made the black angle a little bit bigger, so you can see that it overlaps with the entirety of the yellow angle and some of the purple angle. And there's also some overlap between green and yellow. As a result, here, the sum of the exterior angles will be greater than 360 degrees, not equal to. You might be thinking that this has only stopped working because I drew the yellow angle where I did. And perhaps if I drew it on the inside of the shape, maybe the whole thing would still work. So let's try that example. We'll go back to our original shape and replace one yellow angle with the second yellow angle. And again, let's bring them all together. And we'll see that that yellow angle now both overlaps with the black and the purple angles. So we still have more than 360 degrees here. So still, the sum of exterior angles is not 360 degrees. So we found a boundary where this property of shapes doesn't work anymore. This property only applies to shapes that are not concave. So for all the exterior angles to sum to 360 degrees, the interior angles of the shape must all be less than 180 degrees, unlike this last shape that we've looked at. I'm going to leave that there for this video. I think this is the first video I've done on the properties of shapes, and I quite enjoyed animating it. If you enjoyed this video, feel free to give it a like, and don't forget to subscribe to find your way back for more mathematical content. Thanks, guys.